Good day, this is Moritz from Carbon Neutral Approach. Welcome again to our YouTube channel. If you remember my last video, I showed you some of the hardware that we have on offer at Carbon Neutral Approach. So today is just a quick revision of the stuff that we already have. And as said last time, watch this space for new development. Today I want to show you what the new developments that we've got. Just to recap, this is our main controller. This would form the hub of a network of controllers. The main controller here has 8 analog inputs and 8 digital outputs. The digital outputs are 10 amp relays on board with a normally open, common and normally closed function, which then makes it easy to switch equipment on and off. The connectivity in the unit is an onboard GPRS modem, onboard Wi-Fi modem. Internet connectivity can also be achieved through LAN or local area network via this Ethernet port over here. We have a USB port which allows you to connect to a desktop or a laptop if you want to run dashboards on the larger screen. And then connectivity through a larger network is done through RF. The range that we're talking about between the radios is up to 15 kilometers, or for those of you who measure in body parts, 15 kilometers is about 9 miles. We have tested the radius up to 27 kilometers, which is about 16 miles if you're still measuring in body parts, but we like to stick to the 15 kilometers. So if you need to measure, for instance, more than 8 instruments and switch on or off more than 8 pieces of equipment like pumps and mixers and whatever, it's possible to expand the device with our network expansion units or remote terminal units, which I'll show you just now. Here we are with the whole range of products that we have. As I said, if you want to expand your network and measure more than just 8 instruments and switch on more than 8 pieces of equipment, firstly we have this larger unit over here, which can be configured either as 24 digital outputs and 16 analog inputs, or alternatively 24 analog inputs and 16 digital outputs. The smaller unit over here has very much the same as the larger unit. It has 8 inputs and 8 outputs, again digital outputs. And then if you need to switch or measure just 1 or 2 instruments and switch just 1 or 2 pieces of equipment, we have our smaller units here with 1 digital input, 1 analog input, 1 digital output, and 1 analog output as well. So what I want to talk to you today about is how we've configured these units. This is the new development that I was talking about. Because we developed the hardware ourselves, we can basically configure it in any which way. So normally how it happens is you'll have the main controller that is, let's call it, in charge of the whole network, and you have the remote terminals that would sit and wait for a prompt from the main controller to find out what status it is in and what status it maybe should be. So you can't have these remote terminal units transmitting data all the time because they'll congest the network. So that would make it difficult to have this unit, let's say, talking to this unit if it's an off-the-shelf thing, if you don't have access to the firmware and the onboard support programs and so on. So what we've done in this case is we've reconfigured 2 of these units to act as a small network on their own. So one of them becomes a slave and one of them becomes a master. In this case here, this is the master and this is the slave. So the remote terminal with the range of 15 kilometers, this can be put to measure an instrument, and this could be placed to measure or take the inputs from here and be used as a speed variable for a VSD in the case of irrigation, for instance. How we've also configured it is if there's a loss of communication between the two units, there's a digital relay inside that will toggle and switch off a pump. If the instruments that's being measured by this is a process critical instrument, and failure to communicate with that instrument could cause damage on this side here, we've worked in the safeties. So I'll quickly show how they work. And I'll do this through these little multimeters. It's not the world's most expensive and most accurate measuring equipment, but it will suffice for this exercise. So this is a current generator. So this puts in a milliamp current into the slave here, which is then mirrored by the master on this side here, and that can become an output that goes into a VSD to control speed or something like that. So as you can see, that's pretty close, and if I turn this little wheel here, this will go up or down, and it should be mirrored on that side there. So let's turn this up a bit. We're going to 14 milliamps or so, and it is mirrored on that side there, and going down again also. It's mirrored on the other side, and it's quite quick, as you can see. The communication is it's very fast, so it's quite a useful tool as a safety device. So as I said before, if communication is lost between the two units, let's say for instance now your transmitter, this one here, has lost power for whatever reason, there's a relay in here that should toggle, and you should see a change on the display. Now we've given it a few seconds because to prevent fluttering. So if a loss of communication happens and it's just for an instant, that you don't have a pump switching on and off and so on. So this unit will wait a few seconds, and loss of communication will achieve by cutting the power to the unit. So this is the power input, and you'll see in a few seconds the voltage will drop, and you'll hear a relay toggling in the unit over there. There the relay toggles, and the milliamps have dropped. The relay toggling is also for a few seconds to simulate, for instance, a push button to allow a contactor to unlatch. So that we've done that for the purpose of integrating into existing hardware. So you don't need to go to existing plant or existing farm and replace everything that they have on site. The normally closed circuit from this relay could be, for instance, just wired into the red push button, which is a normally closed circuit, and the 3-second push button function allows the unlatching of the contactor. So when communication is established again, you'll see that the milliamps immediately starts registering again. So it's a very, very quick re-establishment of the communication. And we've done the same if this unit, for whatever reason, loses communication with the main unit, and there is a pump or a piece of hardware that needs to be protected after a loss of communication. The same thing will happen. You won't see a change on the multimeter here because this emits current that's measured over a resistor in there. So the resistor remains. You'll just hear the relay toggling on the inside after a few seconds. So the milliamps have dropped to 0. And in a few seconds the relay will toggle. There the relay toggles, which now would save a piece of hardware. And the same with this one here. It's a few second relay to simulate a push button function to allow the unlatching of a large contactor in the wiring setup. So yeah, this is our what's useful about the radio communication is in an application where you have to lay cables a certain depth because of, let's say, a plow depth at a farm to prevent the cables from being ripped up with agricultural equipment. It becomes quite expensive to lay the cables. So wireless communication, this is a very cost-effective little kit, these two units there, that negates the need for cables, and with a range of 15 kilometers, including the fact that all our radios are configured in such a way that they would act as a in a repeater function. So if one of the units happens to be out of range of the main controller, the signal can be bounced over one of the other remote terminals in a relay situation that allows for continuous communication. So thank you very much for your attention. Keep an eye on. We're still busy developing more stuff, and as it goes along, I'll show you. Thank you very much. Please like our channel. Bye.